All right there, friends. Hopefully you stretched those brain cells a little bit and found some solutions to this problem. Again, this is stuff that when you first look at it might seem overwhelming, but a great strategy in times like this, you always go back to your first principles, okay? You have some basic math skills. You've got some things that you're given. You apply them. Let's get some solutions here, okay? If we make mistakes, that's okay. We go back, we undo, we'll do it again. Let's give it a try and let's see what we can find, okay? So we have this example. First things first, we're given some formulas. We're told that our demand formula is, so the demand formula, P is equal to 200 minus 2Q, okay? You could actually plot that and get a demand curve. We're also told that your supply function is summarized by the formula P equals 20 plus Q. And you could also take that, insert a couple of different Qs, find the appropriate Ps, and then plot that out too. So just with these, you could plot out supply and demand curves, which we'll do in a bit. But our first task, task number 1, we have to find the equilibrium price and the equilibrium quantity. Well, don't panic. You know that equilibrium simply occurs where supply equals demand. So what we will do is we will take these two equations and we'll set them equal to each other. If this is a demand equation and this is a supply equation, supply equals demand is equilibrium. So equilibrium has to be at the point where 20 plus Q equals 200 minus 2Q. If you tweak those around a little bit, you would find that 3Q equals 180, and therefore Q equals 60. The equilibrium quantity, 60. Now, we've got to get the price. That's easy. Let's just take this Q of 60 and dump it into either of these equations. So on the demand side, we said that P equals 200 minus 2Q equals 200 minus 2 times 60 equals 200 minus 120, so P equals 80. And now we have our equilibrium price of 80. If you're really, really uptight and you want to triple check this, let's dump this Q equals 60 into our other formula. P equals 20 plus Q equals 20 plus 60 equals 80. And yep, we confirm. So, all right, good stuff. We have equilibrium quantity of 60, equilibrium price of 80. Equilibrium price, quantity, done. Now let's move on to putting these in a graph and identifying and calculating consumer, producer, and total surplus. Let me make some room here. What you would want to do next would be draw a simple supply and demand graph, okay? So let's do that next. Make some space, get it clean, and we know that Q0 is 60. We know that P0 is 80. Now, let's draw P0 and Q. Now, the first thing that we need to do is figure out where to put our supply and demand curves, okay? If you think about the fact that your demand function is equal to P equals 200 minus 2Q, you can do two different operations. You can set price at 200, and if price is 200, then 200 equals 200 minus 2Q, 0 equals 2Q, and you would know that at a price of 200, quantity equals 0. So at a price of, let's say, 200, quantity equals 0. So this would be 1 point on our demand curve. Then you go the other way. Since we set the Q equal to 0 and got a price of 200, let's set price equal to 0. Price equals 200 minus 2Q. 0 equals 200 minus 2Q. Negative 200 equals negative 2Q. And therefore, Q equals 100. So if price is equal to 0, right here, Q will be equal to 100. And that's our other point. And by simply connecting those, you get D0. Okay? So you have to use a little bit of basic algebra, but really what you have to use, just a little bit of logic and a little bit of creative thinking, out of the box thinking. So we've got our equilibrium quantity, our equilibrium price, and our demand curve. We're almost there. We need to plot a supply curve. Well, same idea. Let's take our supply function, P equals 20 plus Q. If we set Q equal to 0, then P equals 20 plus 0, and that would give us P equals 20, and that's going to put P 20, Q 0, a point right there. Now, you could go the other way and figure out some other points, but there's actually an easier way to do it. We can do this. Let's just, for whatever reason, draw a supply curve. You know, it's going to look like this. And what we know already is that at equilibrium, let's pull these two numbers down. The equilibrium price is going to be 80, and the equilibrium quantity is going to be 60. And at this point now, you have a graph, and you are now able to calculate your consumer surplus, your producer surplus. Sorry, I should have indicated that this was 20. And critically, your total surplus. Simple formulas, let's do it. For consumer surplus, it's a triangle. 1/2 the base times the height. Again, consumer surplus will be here. So your height is going to be 200 minus 120. And your base is going to be 60. Equals 1/2 120 times 60 equals 3,600. You crunch out your numbers, you're going to get a consumer surplus of 3,600. That is the area of this triangle. Okay? So far, so good. So we have our consumer surplus, 3,600. Producer surplus time. Producer surplus, it's still a triangle, except this time it's this triangle. As a triangle, it's still going to be 1/2 base times the height, except now, here's your height, same base. 1/2 of base times height equals 1/2 of 80 minus 20 times 60. 1/2 of 60 times 60, or 1,800. Now you have your producer surplus. And once you have producer and consumer, you can calculate total in one of two ways. For your total surplus, you can actually go and figure out with the 1/2 base times height, the area of this triangle, or you can just add together your producer and consumer from before, but either way, your total surplus is going to be $5,400. That's the area of that triangle that represents the gain to buyers and sellers when they buy and sell. So now we've got equilibrium price, check. Quantity, got it. Consumer, producer, and total surplus, got it. And let's just remind ourselves that this is 5,400. Next question, question number 2. What is the effect of a $60 price floor? Well, first things first, we have to find $60. We're going to put that right here in black, and we're going to draw a line. Remember that a price floor is a limit and a price can't go below it. So a price floor is an artificial maximum price. Notice in this case, again, as a floor, the prices cannot go below it, so prices cannot go below it. But notice, this is a trick question. In this case, the price floor level is actually below the equilibrium price. Therefore, the price floor will not have any impact on equilibrium because the price floor is below it. We would call this a non-binding floor. In other words, the answer of the effect, it's going to have no effect. Because if prices can't go below 60, but 60 is already below the equilibrium, it's non-binding. So there you go. Question 1, question 2, we got it. Now we got to do question 3. And this one's going to be a little bit hairier. So let's first start off by cleaning up a graph. We'll sketch out a fresh one. We'll have to do a little bit more calculations, but we'll get it. Q, 0, and P. We know that we have a demand curve that goes from 200 down to 100 demand, and the supply curve that starts at 20 and that it's going to hit here 80, 60. Nothing new. Now, however, we ask the question, what's the impact of a $100 price floor? And now we're going to have something happening because the $100 is up here. So this is going to be a floor. And because this floor is above equilibrium and it therefore will fulfill its job of keeping prices from falling too low back to equilibrium, this is going to be a binding floor. And therefore, it's going to cause us some economic inefficiency, specifically a dead weight loss. How do we calculate that dead weight loss? Well, we first start off by realizing that if the price is set at $100, buyers will buy less. Again, at the price of 100, the demand curve will hit here. So that's going to be our new Q. And at that, we have to figure out what the Q is. We're also going to notice that at this new Q, it's going to hit the demand curve at 100. That's easy. But we have to figure out right here what that is. Remember, we're calculating a triangle, so we have to know the extreme ends of it. Let's figure it out, and then we'll be set. Up here, we know that on the supply curve, the price is equal to 20 plus Q, right? Therefore, we know that the price is equal to 20 plus 50. Actually, you know what? Take that back. Sorry about that. I need to do another one first. My apologies. Let's do the Q first. My apologies. I don't want to jump ahead. Let's figure out this variable, okay? So we know that we're talking about the point where $100 intersects the demand curve. That's what we're finding here. So let's do it this way. We know that for the demand curve, price is equal to 200 minus 2Q. Therefore, 100 is equal to 200 minus 2Q. Therefore, negative 100 is equal to negative 2Q. And therefore, Q is equal to 50. So this will be 50. Sorry, I took that shortcut. Now that we have that, we can solve this because we're talking about a supply curve. The supply curve function was P equals 20 plus Q. Well, we know that we have the Q here of 50. So P will equal 20 plus 50 will equal 70. And now that we have all these points together, now, my friends, we can calculate our dead weight loss. Let's get some space and let's do it. The dead weight loss, again, my friends, is simply this triangle here. Notice that we're talking about a triangle that is bordered by 100 up here, by 70 down here, by 50 right here, and by 60 right there. Now you have the base and the height. The dead weight loss is equal to 1/2 base times height is equal to 1/2 60 minus 50, 10 times 100 minus 70, 30 equals 1/2 of 300 equals 150. We are saying, my friends, that this price floor, this innocuous, it seems innocent price floor of $100 that is probably going to be sold politically to help a lot of people out, is actually going to harm this economy with a dead weight loss equivalent to $150. That is the overall decline in society's well-being when this flawed policy is passed. If you really want to double check your numbers, you can take this and you could determine the consumer surplus here, the producer surplus and the transfer amount here. And I bet that if you did that right, the area of this triangle, actually this quadrilateral here, plus 150 should give you 5,400. Okay. All right. That's a lot of numbers. That's a lot of math. The point of all this was to get you thinking critically, to get you thinking about problem solving in an unconventional, out of the box way, and to get you bridging your economic skills and your math skills to find some really, really comprehensive and actual quantifiable policy recommendations. As in, hey, Mr. Politician, I recommend that you do not pass this floor because you are going to hurt society to the tune of $150 of lost value. That, my friends, are your solutions. If you have any questions, bring them into Lifetime office hours and we'll go through it. Thanks, and I'll talk to you soon.